Welcome to another AP Computer Science lesson. Be ready to buckle down and learn about arrays, which is an alternative to the array list studied in Lesson 15. The syntax of an array looks like this in Java. An array is similar to an array list, which is a linear data structure composed of adjacent memory locations, or cells, holding each value of the same type. The variable a is an array, a group of 6 related scalar values. There are 6 locations in this array referenced by indexes 0 through 5. Note that the indexes always start from 0 and count up by 1 into the last slot of the array. If there are n slots in the array, the indexes will be 0 through n minus 1. The variable loop is used for a for loop to reference indexes 0 through 5. In this program, the square of each index is stored in the memory location occupied by each cell of the array. The syntax for accessing a memory location array requires the use of some square brackets. The square brackets are collectively an operator in Java. They are called the index operator. They are similar to parentheses and have the highest level of precedence compared to all other operators. Index operator performs automatic balance checking. Balance checking makes sure that the index is within range of the array being referenced. Whenever a reference to an array element is made, the index must be greater than or equal to 0 and less than the size of the array. If the index is not valid, the exception array index out of bounds exception is thrown. Array declarations look like this. This tells the compiler that array name will be used as the same name of the array containing type. However, the actual array is not constructed by this declaration. Often an array is declared and constructed in one statement like this. This tells the compiler that array name will be used as the name of the array containing type, and constructs an array object containing length number of slots. An array is an object, and like any other object in Java, is constructed out of the main storage as the program is running. The array constructor uses different syntax than most object constructors. Type length names the types of the data stored in each slot and the number of slots. For example, once an array has been constructed, the number of slots does not change. The size of the array can be defined by using a final value. When an array is declared, enough memory is allocated to set up a full size of the array. Suppose that we have a text file votes.txt of integer data containing all the votes in an election. This election happened to have 3 candidates, and the values for the integers file in 1, 2, or 3, each corresponding to one of the 3 candidates. The array data consists of 4 cells, each holding an integer value. The first cell, data 0, is allocated but not used in this problem. After processing the entire file, the variable data n contains the number of votes for candidate n. We could have stored the information for candidate 1 in 0, candidate 2 in position 1, and so forth, but the code is much easier to follow if we use direct correspondence. In the following list, we introduce 5 important algorithms that are quite common in programs that analyze data in arrays. You'll meet these again in later lessons and labs. Insertion is a standard problem that must be solved for all data structures. Suppose an array had 10 values and the 11th value has to be added. We are assuming that an array can store at least 11 values. If we place a new value at the end, there would be no problem. But if a new value must be inserted at the beginning of the list in position 0, the other 10 values must be moved 1 cell over in the list. Deletion of a value creates an empty cell that probably must be dealt with. The most likely solution, after deleting a value, is to move all values that are to the right of the empty spot 1 cell to the left. A transversal of an array consists of visiting every cell location, probably in order. The visit can involve anything like printing out the array, initializing the array, finding the greatest or smallest value in it, and etc. Sorting an array means to organize values in either ascending or descending order. Searching an array means to find a specific value in the array. There are several standard algorithms for searching an array.